Hi there, in this video I'm going to go over partial fractions C4. We'll cover three cases. The first case is where you've got linear factors at the bottom, second case where you've got quadratic factors, and then finally where you've got repeated linear. We'll then look at how partial fractions can be applied to binomial expansion. Let's look at the first case. We've got partial fractions linear factors, so we've got linear factors at the bottom, and the way to treat this is to separate them out as separate fractions and write the numerator as a constant. Okay, so let's see how this works. So we've got x minus 9, okay, divided by x plus 1 times 2x take away 3. Okay, and we'll separate these out. So we'll say this equals a divided by x plus 1 plus b divided by 2x take away 3. Now we can see that to get rid of the denominators we simply multiply top and bottom by, let me just take the highlighter out, by this denominator, and by doing so we then get x minus 9 equals a times 2x take away 3 plus b times x plus 1. So that's having multiplied top and bottom by x plus 1 times 2x take away 3, and then the x plus 1 here cancels, and the 2x minus 3 cancels, and so we have that. Now to work out a and b, what we'll have to do is substitute some values of x, and we can start by looking at, say, this bracket here. You've got x plus 1, and if we were to set that to 0, we've got x equals minus 1. So we can sub in x equals minus 1, and naturally b will disappear. So if we sub in x equals minus 1, we get minus 1 take away 9, which is minus 10, equals minus 2a and then plus 0. And so that gives us a equals 2. Now similarly we can sub in, so if we make 2x minus 3 equals 0, x equals 3 over 2, but that leads to unnecessary complications with fractions. What we could do instead is substitute x equals 0, and then we've got minus 9 equals minus 3a plus b. We know what a is. A is 2, so you've got minus 9 plus 6, and therefore b equals minus 3. And so therefore our fraction x minus 9 divided by x plus 1 times 2x take away 3 equals 2 over x plus 1 minus 3 over 2x minus 3. Right, let's look at this case. You might want to pause the video and have a go at doing this. So in this case, our partial fraction, we need to factorize it if we can, and if we do factorize it we get x minus 1 and x plus 2, and then we can separate them out as a over x minus 1 plus b over x plus 2, and then if we multiply through by x minus 1 x plus 1, in other words if we multiply through by the denominator here, then we get 1 equals a x plus 2 plus b x minus 1. And then if we substitute in x equals 1, then the b obviously goes to 0, and you get a equals a third. If we then substitute in x equals minus 2, then this part goes to 0 and you get b equals to minus a third. So therefore our original fraction can now be written as x minus 1 x plus 2 equals 1 over 3, because it's a third, times 1 over x minus 1, take away 1 over 3 times x plus 2. Right, now let's look at a case where we've got a quadratic factor at the bottom times, say, a linear factor, and we know with the linear factor we just put a constant at the top. With the quadratic factor, because the highest power here is a 2, the numerator will be 1 power less, so it'll be ax plus b. If the denominator was a cubic, the numerator would be a quadratic. And that also helps, I guess, explain why when we've got a linear here we have a constant at the top, because it's 1 power less. So in effect that's x to the power 0. So if we want to, let's look at an example. So you've got 2x plus 1 over x squared x minus 2, and we'll write this out as that fraction. We'll write this out as ax plus b divided by x squared plus 1 plus c over x minus 2. And similarly, by multiplying across by x squared x minus 2. Okay, so let me just highlight the part we'll use to multiply through. It's just simply the denominator here. So if we were to multiply by x squared plus 1 times x minus 2, then that leads to 2x plus 1 equals ax plus b times x minus 2 plus c x squared plus 1. Now to solve this, what we could do is substitute x equals 2 into here, and this, the whole part becomes 0. We're left with 2x plus 1 equals c, x squared is 2, so 5 times c, and then equals 5, so c equals 1. And then similarly, by substituting in x equals 0, we're left with this part equal to 0, and we're left with 1 minus 2b plus 1, and therefore b equals to 0. And then if we were to sub in, or in fact if we were to equate the coefficients, so with the to find out a, what we could do is equate the coefficients. Let's go back. Right, that's better. So we'll equate the coefficients of x squared, and on the left hand side we don't have anything, and on the right hand side we have ax. So maybe it's good, maybe I'll highlight this. So we've got ax times x gives me x squared, and we also have the cx plus 1. So if I take out the coefficients from those values, we have a plus 1. Therefore a has to be minus 1. And so we can write the fraction 2x plus 1 divided by x squared plus 1 times x minus 2 as simply minus x over x squared plus 1 plus 1 over x minus 2. Let's now look at the case where we've got a repeated linear root, so ax plus b squared, and the way this sort of carries on, it follows a pattern where you've got ax plus b to the power 1 and then ax plus b squared. At the top you've got coefficients. Now one might think that if you were to take this, I'll just write this out in red and then delete it later on. So you might think you can write this out as a over ax plus b plus c over ax plus b, since it's repeated at the bottom. But that just gives you a plus c at the top and ax plus b at the bottom, which won't satisfy this fraction, since we've got an x in there as well. And so we'll write it out in this form. And let's have a look. Let's look at an example. So we've got 3x minus 1 over x squared take away 4x plus 4. Then we've got, let's write this out, 3x minus 1 over x minus 2 all squared, so that's factorized. And then we'll write this out as a over x minus 2 plus b over x minus 2 all squared. So if we multiply through by x minus 2 squared, so let's just do that. So if I just multiply by x minus 2 all squared, then this just gives me 3x minus 1 equals a x minus 2 plus b, to just put b by itself. And then here we can substitute, we can substitute x equals 2 in, and then that will give us x equals 2. So we've got 6 take away 1, which is 5, equals 0 plus b. Therefore b has to equal to 5. And then if we were to equate the coefficient for the x part, let me just bring this down. So then if we were to equate the coefficients of x, we get the 3x equals a, because that's only x parts that we have. And so therefore we can write our original fraction as x minus 2 squared. This is simply 3 over x minus 2 plus 5 over x minus 2 all squared. Right, you might want to pause the video and have a go at doing this question. Right, so in this question we've got a repeated linear root times a linear root. So it follows the same pattern. The repeated linear root would just be ax plus b squared, and then plus a cx. So faster just write this down. So you've got 2x squared plus 7 divided by 2x plus 1 all squared times x plus 3. This equals, right, so this will just give us a over 2x plus 1 plus b over 2x plus 1 all squared plus c over x plus 3. Let me just put that in. Right, so over here we have to multiply through. Then we've got 2x squared plus 7 equals a 2x plus 1 times x plus 3 plus b x plus 3 plus c 2x plus 1 all squared. So what we've basically done is to multiply through by this denominator over here, and then it's got rid of the fraction form and put it in an equation as so. And now we just need to substitute various values for x. So if you substitute x equals minus 3, this should lead us to c equals 1. So we'll get 0, 0 over here. And you've got minus 6, sorry, minus 6 plus 1 would give us minus 5. 5 squared is 25. And then similarly here we'll have 9. 9 times 2 is 18. 18 plus 7 is 25. So therefore c equals 1. Similarly, if we then substitute x equals a half, the half comes from here, so 2x plus 1 equals 0, so x equals minus 1 over 2. Let's put the minus in. Let me in fact write that out so it's a bit more clear. And therefore this should give us b equals 3. And finally, substituting x equals 0, this should lead us to a equals minus 1. And so therefore we can write our fraction as 2x squared plus 7 divided by 2x plus 1 all squared times x plus 3. This equals minus 1 over 2x plus 1 plus 3 divided by 2x plus 1 squared plus 1 over x plus 3. Right, finally, let's now look at how the binomial expansion can be how partial fractions can help us with binomial expansion. Now, with something like this, we could write this as x minus 1 to the power minus 1 times 2 minus x to the power minus 1. Do the expansion up to the x cubed terms, and then multiply through. However, maybe we can simplify this whole situation by using partial fractions. And so if we were to take this case and let's just write it out as a partial fraction first. So x minus 1, 2 minus x is simply a over x minus 1 plus b over 2 minus x. Okay, this leads to, if you were to solve this, multiply through. So if you were to substitute in x equals 2, we get b equals to 1, and if you were to substitute in x equals 1, then we should get also a equals 1. So therefore our fraction 1 over x minus 1 times 2 minus x equals 1 over x minus 1 plus 1 over 2 minus x. Now this can be written as x minus 1 to the power minus 1 plus 2 minus x to the power minus 1, and to put them in the form so that we can use a binomial expansion, the binomial expansion, remember, should be written in the form where you got 1 plus or minus kx to the power minus 1. So to put it in that form, what we'll do is to take out the x, so we can flip this, so it's minus 1 plus x, take out the minus 1, sorry, so you've got minus 1, 1 minus x to the power minus 1, and this is minus x plus 2, so we could take out the, sorry, this is 2 minus x, so we could take out a 2, so we've got 2 to the power minus 1, 1 minus x over 2 minus 1, and then we can do the binomial expansion on each of these parts. So 1 minus x to the power minus 1 simply gives us 1 what plus minus 1 times minus x plus minus 1, take away 1, divided by 2 factorial times minus x all squared, and then similarly we've got, write this in, minus 1 times minus 2 times minus 3 over 3 factorial times x cubed, and this gives us 1 plus x squared, and this is valid, we know it's valid for x is greater than minus 1 or less than 1. Similarly, our other expansion where you've got 1 minus x over 2, you might want to pause the video and have a go at doing this. This gives us 1 plus a half x plus a quarter x squared plus 1 over 8 x cubed. And this we know from what we've got in the bracket that it's valid for x over 2 being greater than minus 1 and less than 1. If we multiply through, we get x is greater than minus 2 or less than 2. If we were now to combine these, we'll get, so because don't forget at the top we've got also these coefficients here at the front of the expansion which we haven't put in during our expansion. So if we were to bring them back in, then we've got 1 over x minus 1 times 2 minus x equals minus 1 plus x squared plus x cubed, and we only need to know up to the x cubed term, plus a half 1 plus x over 2 plus x over 4 plus x cubed over 8 Okay, and this will give us, we'll expand it out and add them together, and give us minus a half take away 3 over 4 x minus 7 over 8 x squared minus 15 over 16 x cubed. Now, what is the expansion valid for? Which values of x? Initially, for the first expansion, we had was between minus 1 and 1, and then we had between minus 2 and 2. And we've got to pick a region that satisfies both of them, and therefore we'll choose minus 1 and 1 because that naturally covers the other region as well. So therefore we know that this expansion is valid for x is greater than minus 1 and less than 1. So there you have it. If we go back to the first page, we've covered 3 cases of partial fractions. One where you've got linear factors, then you've got quadratic factor, and you've got a repeated linear factor, and we've seen how that can help us to do the binomial expansion.